Means it need not be a laboratory experiment first. Is it? You are doing something. Suppose you are cooking. That is also an experiment. If that outcome is tasty, very good. That experiment is a successful experiment. Otherwise, it is a failure experiment. You are trying to cook something or not? Is it right or not? Maybe every day or some days, maybe at least once a week, you are trying to cook something. Sometimes it is tasty, sometimes it may not be having good taste. Is it? Means if it is tasty, that experiment is a successful experiment. Otherwise, it is a failure experiment. You are observing something. I am also trying to improve my writing skill, and my writing is not so good. I know. Is it? I am trying to improve my writing skill every day. So if I improve every day, maybe partially success. Okay, one day or other day, if my rating is looking so good, okay, that experiment is a successful experiment. Otherwise, it is a failure experiment. Means experiment means need not be a laboratory experiment. Every incident in our daily life is also an experiment. Every incident is random. What is deterministic experiment? Deterministic experiment means if I know the result clearly, what is going to happen if I know clearly, that is a deterministic experiment. Sun rises in the east. Sun rises in the east. Very clear. Tomorrow morning, not tomorrow, every day morning sun rises in the east only. That is a deterministic experiment. Why? Because what is going to happen tomorrow, you know now only. Not only me, everyone know. Is it right or not? Yes. Boiling point of water is 100 degrees centigrade. Yes. What is boiling point of water? If I ask a question, everyone say that is 100 degrees centigrade. Is it? So, means what is the result already you know in the beginning only before conducting that experiment itself. Sun sinks in the west. Okay, that also you know. Is it? Yes. Before conducting the experiment itself, easily you can. Color of a sea is blue. Is it? Yes. Ocean color is a blue or sky color is a blue. These are the examples of deterministic experiment. Now, here one clear observation. If I ask a question, what is the chance of sunrise in the east? If I ask a question like this, generally, what is the chance of sunrises in the east? If I ask a question generally, how can you give reply? What, sir? Everyone knows sunrises in the east tomorrow, day after tomorrow. Okay, even after 100 years also sunrises in the east only. Why you are asking the chance, sir? Is it? Will you put a bet on that? Bet. My bet is so and so rupees. Sun will not rise in the east. Anyone put a bet on that? Definitely no. If you put a bet on that, definitely we are all foolish. As a tractor, foolish persons. Why? Because sun rises in the east is very clear. Deterministic experiment. For all deterministic experiment, no need to use the word chance. Is that right or not? What is the chance of sunrise in the east? Wrong question. Invalid question. What is the chance of color of the ocean is blue? Invalid question. Invalid question means no use. Already I know the answer. Is it? So, is probability. Probability and chance both are synonyms only. Is it? So, for deterministic experiment, we will not use it. Second model of experiments, random experiment. Random experiment means, for example, today I think there is a match between India and England. Is it? Semi-final match between India and England. Who is going to win? That is our prediction only, not exactly. Is it right or not? Yes, because we are all Indians, we are favorite to our country only. Generally, Indian cricket team is going to win. We are giving like that all. Okay, means that is our prediction. If I ask a question, yes, some of you may say, sir, 100%, sir. Some of you may say, sir, 50%, sir. Some of you may say, no, sir, England is also, they are doing well. Okay, England also may win, sir. England, India winning is just 25% only, some of you may say. Here, there is a flexibility because outcome I don't know. Who is going to win? Result is unpredictable. Is it right or not? Result is unpredictable. So, here we can use the word chance. Okay, suppose if a coin is tossed, what result? Is it head or tail? I don't know. Result is unpredictable. Here also I can use the word chance. What is the chance of getting a head? What is the chance of getting a tail? Like that we can. If a die is rolled, What is the chance of getting a number 4? Because I don't know the outcome. In all such cases, we can use the word chance. So experiments are two types. One is deterministic experiment, second one is random experiment. Probability or chance, we can ask for random experiments only, not for deterministic experiments. Is it right or not? So now here one clarification. So that is a reason in every book you can observe the random experiment as a definition. What it is? What is random experiment? An experiment where the result is unpredictable. The result is unpredictable is called random experiment. Example, tossing a coin. Example, throwing a die. Number of such examples you can. Okay, leave it. Now the information as per the definition given. Now leave all these definitions again. No need to write, we'll upload. Don't worry. Wait some time. You just see this clearly, observe it. If any important point you feel, you write it enough. Say this now. I don't know basic definition of probability, you just assume. Even random experiment definition also I don't know. What is experiment, what is random experiment, that also I don't know. Very simple question. 9th or 10th class standard level question I am asking you. If a single coin is tossed, what is the chance of getting a head? If a single coin is tossed, what is the chance of getting a head? 1 by 2. Tell me. Those who are sitting in last benches, if it is not visible to you, come here. There is a place here. Say, once again I am asking you, if a single coin is tossed, what is the chance of getting a head? 1 by 2, na? How you are giving that answer 1 by 2? In earlier class only, in 10th class only, our mathematics teacher taught the chance of getting a head is 1 by 2. That's why you are giving an answer is 1 by 2. Clear? I am not asking like that. I am not asking like that. Logically, you try to answer the question. Logically. Complete logic. Probability means complete logic. Once you start to use a formula, confusion starts. If a single coin is tossed, just like a layman, just like a illiterate, you just answer this question. Say this. Listen carefully. I am an illiterate, I don't know anything. I don't know probability definition and spelling also. Suppose a single coin is tossed. Okay, with our imagination, single coin is tossed. For a coin, there are two possible outcomes. Tell me, what are they? Head and tail. Head may comes as an outcome or tail may comes as an outcome. Okay. Both head and tail are having equal chances or not? Both head and tail are having equal chances. Now tell me, what is the chance of getting a head? 50%. Is it right or not? Chance of getting a head and chance of getting a tail both are having equal chances means for a head 50% chance is there. For a tail also 50% chance or not? 50% means what it is? 50 per 100. Percentage means 50 per 100 or not? 50 per 100 means it is 1 by 2. In percentage wise, 50, if you convert it into a number 1 by 2, both are same. See, from this 1 by 2, what is your observation? If a single coin is tossed, all possible outcomes are nothing but head and tail. All possible outcomes are nothing but head and tail. I will take it as a set. That is a universal set. Complete set theory. Head and tail. So, what is denominator? Number of elements. What is denominator? Number of all possible outcomes. That is a denominator. What is required to me? Head required. I will take it as an event. Event is equal to head. What is required to you? That is a part of the sample space. So, one is nothing but the number of elements of an event. So, whenever you conduct an experiment, so first you write the sample space. What is sample space? Number of all possible outcomes is nothing but a sample space. All possible outcomes. Now, what is required to you? See, sample space is the all possible cases. Among all possible cases, what is required to you that you can write as an event? That is a subset of the sample space. What is required to you? That is a subset of a sample space. So, what is probability? Probability we can define for any event. Probability of getting a head is nothing but n of e by n of s. That is nothing but 1 by 2. Numerator is a, see, denominator is the number of all possible outcomes. Numerator is a part of the denominator. Okay, that is a subset. Simply, denominator is a universal set in a set theory. Numerator is a our question. That is a part of the denominator. That is a subset of the universal set. Complete set theory. And every question is a subset of the universal set. Universal set is nothing but the complete sample space. For example, you say this. Suppose if a single die is rolled. If a single die is rolled, what is sample space, you tell me? If a single die is rolled, what is die? Die is a six-faced cube marked with the numbers 1 to 6 or not? Yes. If a single die is rolled, what are all possible outcomes? 1, 2, 3, 4, 5, 6. Clear or not? Yes. Now, irrespective of the question, this is very crucial observation, you listen. Irrespective of the question, denominator is 6 and why? Denominator is the number of all possible outcomes or not? Number of all possible outcomes means number of elements in a sample space, that is a denominator irrespective of the. Now, from that, I will ask different questions. I will ask different questions. Now tell me, what is the chance of getting number 5? And what is the chance of getting number 5? 5 by 6, huh? How many such 5s are there? Only 1 5. 1 by 6. What is the chance of getting a number 2? Is it not 2 by 6? 1 by 6 or not? What is the chance of getting an even number? How many even numbers are there? 3 even numbers. On means 3 by 6. 3 by 6 means is it 1 by 2 or not? What is the chance of getting a 3 by 6? What is the chance of getting a prime number? How many prime numbers are there? What are prime numbers first? 2, 3, 5. 1 is neither prime nor composite. Okay, 1 is neither prime nor composite number. 2, 3, 5 are prime numbers. Again, what is the chance of getting a prime number? 3 by 6. Again 1 by 2. Now tell me, what is the chance of getting a composite number? How many composite numbers are there? 4 and 6. Number which is not prime is called composite. What are the prime numbers? 2, 3, 5. 1 is neither prime nor composite. So remaining are nothing but composite numbers or not? What are the remaining numbers? 4 and 6. Is it right or not? 2 by 6. Okay. What is the chance of getting a perfect score? How many perfect squares are there? How many perfect squares? One, one and perfect square means 1 and 4 are the perfect square. 1 you can write as 1 square, 4 you can write as 2 square, 2 by 6. 2 by 6 means 1 by 3 or not? From a single data, number of questions you can develop. Denominator is the number of all possible outcomes. Numerator is nothing but what is required. Numerator is always a part of the denominator. Numerator is a part of the denominator. First, I will give the sample space definition and event. See, what is required to that question is our event. It is not coming like that. What is sample space? Sample space. The set of all possible outcomes. In a random experiment is called a sample space. It is denoted by notation. Yes. Event. Event is our question. Any subset of a sample space is called an event. It is denoted by capital E. Clearly, every event is always a subset of sample space. Sample space is like universal set. Event is a subset of universal set. Okay. You just say this, no need to write. You are interested, right? If so, write it, write fast. Let me give some important observation, then we'll discuss complete previous gate questions on this area. Example, if a single die is rolled, sample space example I am giving, sample space and then what is sample space? It may be any one, 1, 2, 3, 4, 5, 6. E1 is equal to events, some events I am defining. Event of getting 5. That implies E1 is equal to, it is a subset containing only one element 5. E2, event of getting even number. That implies what is E2? What are even numbers? 2, 4, 6. E3, event of getting prime number. Two, three, five. One minute. Odd I will write because one more definition parallel example I will. What are odd numbers? 1, 3, 5. See, generally sometimes we heard about mutually exclusive events. What are mutually exclusive events? When you say the events are mutually exclusive, any idea? What are mutually exclusive events? Simple. No need to follow any definition. Suppose intersection of any two events is a null set. Means if there is no element in common between any two events, those events are called mutually exclusive events. Suppose if I take E1 intersection E2, what is the intersection of E1 and E2? Is there any element in common? There is no common element. Those are called mutually exclusive with each other. Similarly, what about E2, E3 and E2 intersection E3 also, there is no element in common. Here also E2 and E3 both are mutually exclusive. Okay, next. What about E1, E3? E1, E2, E1, E2 observed. E2, E3 we have observed. What about E1, E3? E1 intersection E3, is there any element in common? Yes, that is 5. So, E1 and E3, they are not mutually exclusive. Examples and counter examples parallelly, because these are also playing very important role later. So, that information also. Mutually exclusive events. What are mutually exclusive? Mutually exclusive events. Two events E1, E2 in a sample space are said to be mutually exclusive. If and only if E1 intersection E2 is equal to 5. If and only if means this implies that one and that implies this one. If intersection of any two events is a null set, those events are called mutually exclusive events. See, already previous examples we can. In previous example, just for clarity, in previous example, E1 intersection E2 is equal to 5. That implies E1 comma E2 are mutually exclusive. E2 intersection E3, that is also 5. E2, E3 are mutually exclusive. But E1 and E3 are not mutually exclusive. E1, E3, yes, you are correct, Amma. E1, E3, there is one element common, that is 5. That's it. If I know the events are mutually exclusive, what is the advantage to solve the problem easily? All these are cameo characters. Cameo characters means supporting characters playing very important role later. Next, sometimes you are using the word independent event. That word also we heard. What are independent events? What are independent events? In the name itself, very clear. Independent. Independent means they are not depending with each other. They are not depending with each other means the happening of one does not depends on the happening of other. Means one event is not affected by the other event. One event is not affected by the other event means any example? Clearly, mutually exclusive events examples given to you or not? In a similar manner, what are independent events? When you say the events are independent, now probability and statistics, now it is presently, you are following that subject. In present semester it is there or not? Is it? Now tell me, you know all this. What are mutually exclusive, what are independent events? You know them clearly. Because it is a present running subject now. Presently is it a running subject or not? And tell me now. CSM కొందా సార్? CSM స్టూడెంట్స్ ఉన్నారమ్మా? CSM ఉన్నామంటే క్వశ్చన్ అడుగుతానా? అందుకే లేవని చెప్తారేమో. ఓకే, రైట్, లీవ్ ఇట్. మళ్ళీ మీ టైం నేను వేస్ట్ చేయలేండి. బట్ చాలా క్లియర్గా వినడమ్మా. జస్ట్ ఐ కేమ్ ఫ్రమ్ లాంగ్ బ్యాక్. జనరల్లీ some of you are not showing interest maybe, but you listen carefully. It will be very helpful to you 100%. Say this. Me independent events. Independent means the happening of one does not depend on the happening of other. Generally, if you follow this subject carefully, some students have a big doubt in their mind. Mutually exclusive event and independent events both are same or not? No. Mutually exclusive events, they never be independent. When independent events will happen? For example, you say this, E1 intersection E2 is equal to 5. What are E1 and E2? See here, E1, getting an even number and getting an odd number. Yes, getting a number 5 is E1, getting a even number is E2. Clearly E1 intersection E2 is equal to 5 means very clear. Suppose if if a die is rolled, number 5 comes as an outcome in the sense, it prevents the happening of remaining all numbers. Means getting a number 5 depends on not getting the remaining numbers. Similarly, even number comes as an outcome in the sense, it prevents the happening of remaining all odd numbers. Means, yes, getting an even number depends on not getting odd numbers. Clearly, mutually exclusive events are depending with each other. They are not independent. When independent occurs, blind observation I will give you. Try to hear me carefully. Suppose a coin is tossed. Observe the outcome. Head or tail, leave it. Same coin, you take it and toss it again. Same coin, you toss second time. No doubt, irrespective of the first outcome, second result will come or not. Irrespective of the outcome, what it is. In first time, maybe head or tail, leave it. Second result is irrespective of the first one only or not. Suppose you toss the same coin third time also, irrespective of the first two outcomes, third result will come. If you repeat fourth time also, first three results, okay, it is independent. Fourth result is independent of the first three or not? Very clear. So, here one observation. What is our observation? Repeated. Is it? Experiment repeated. And one more. Take a die, roll it, observe the outcome. Same die you roll second time. Second outcome clearly does not depend on the first outcome. And same die you roll it third time. No doubt, third result does not depend on first two. In all such cases, here also experiment is repeated. So, blind observation. Whenever experiment is repeated, no doubt, every outcome is independent, default independent. So, to say the events are independent, you have to repeat an experiment. Blind observation. Without repetition of experiment, but in previous case here what it is, if a single die is rolled, this is an example of, if a single die is rolled, within a single die, if I write a sample space for a single die, if I write a sample space contains 6 elements 1 to 6. Within that sample space, you can define number of events, E1, E2, E3, any number of events. They never be independent because experiment is not repeated here. They never be independent. Maybe some of them may be mutually exclusive, some of them may not be mutually exclusive, but independent events not possible because experiment is not repeated here. But whenever you repeat an experiment, by default every outcome is independent. Every outcome is independent. And one more example. More clarity required. Suppose if I give one problem to you, one may answer that problem maybe in 1 minute, one may take 2 minutes, one may take 5 minutes, one may take half an hour. Means here all our IQ levels are independent. All our IQ levels are independent with each other because skill, my skill, your skill, your skill, your skill, all are not depending with each other. All are independent. Is it? But here also one undercurrent observation. What it is? Giving a problem is an experiment. Suppose here 150 students are there, you just assume. Giving a problem is an experiment. Since that problem is given to 150 students, that experiment is repeated how many times? 150 times. Even it is a skill related also. Here also one undercurrent observation. Here also experiment is repeated. Suppose you are going to attend an interview. Maybe all of you are going to attend an interview. Okay. So in interview, again that is a skill only. Okay. One may select, one may not select. One may answer 5 out of 10 questions. One may answer 10 out of 10 questions. One may answer 0 out of 10 questions. There also our IQ, that there also it is a skill related. All our skills are independent. There also one undercurrent observation. Conducting an interview is an experiment because 150 participants are attending. That experiment is repeated 150 times. Means from this overall conclusion, when independent events are possible, I have to repeat an experiment. If I repeat an experiment, by default every outcome is independent. If experiment is not repeated, independent events not possible. Blind observation. Is it? Yes. What are independent events? Now I am writing that definition, you say that. Independent events. Events in a sample space. Two events, E1 comma E2 are said to be independent. The happening of one if they are not depending on each other. Simple. Sir, sir. Ah, okay, sir. Just 2 minutes. Example. If a fair coin is tossed repeatedly, all outcomes are independent. Every outcome. So many examples we can give like this. Now using all this, I will give, already you know what is probability. I will give probability definition. Along after probability definition, we will discuss complete previous gate questions on probability. Is it? Okay, take break for 10 minutes break. After break, we'll continue. Some students are sitting forcefully here. మీ కాలేజ్ వాళ్ళు అలా ఇన్సిస్టెంట్ ఫోర్స్గా అట్లా అట్లా వింటే వినకపోతే వినాలి అనిపించడం ఇంట్రెస్ట్తోనే ఉంది. గేట్ క్లాస్ ఈజ్ ఫర్ ది ఇంట్రెస్ట్ ఓన్లీ. యాక్చువల్లీ ప్రాబ్లం ఏంటంటే సార్, ఫోర్స్ఫుల్గా కూర్చోబెడితే వాళ్ళకి ఆ ఫీల్ రాదు. అంటే ఆ ఎగ్జామ్ దాని తెలియదు కదా వాళ్ళకి. ఏదో మా ఇప్పుడు అదే ఏంటంటే ఆ ఇంట్రెస్ట్ అనేది వాళ్ళకి కానీ అండి యాక్చువల్లీ ఎక్కువ ర్యాంకర్స్ ఉంటారు కదా, వాళ్ళు ఇట్లా అంటే ఇట్లా ఏదన్నా క్లాస్ అప్పుడప్పుడు ఇట్లాంటి క్లాసెస్ ఆన్లైన్ క్లాస్ కొన్ని టెస్ట్ సిరీస్ రాసి మంచి రాసుకోండి. ఆ ఇంట్రెస్ట్ ఉండాలి. ఇంట్రెస్ట్ ఎప్పుడైనా సరే
వాళ్ళకి క్యాంపస్ ప్లేస్మెంట్ తెచ్చుకోవడం గేట్లకి అదొక చిన్న
జస్ట్ ఇమాజిన్ అమ్మా, యాక్చువల్లీ మోస్ట్ ఆఫ్ యూ ఆర్ ఆస్పిరెంట్స్. మీరు ఇంటర్మీడియట్ లో ఉన్నప్పుడు నేను ఐఐటికో ఎన్ఐటికో వెళ్ళాలనే కదా మీరు ఇంటర్మీడియట్ జాయిన్ అయి ఉంటారు. ఏదో కార్పొరేట్ మీరు ఏ కాలేజీలో జాయిన్ అయ్యారు, అవునా? అది మిస్ అయిపోయి ఇంజనీరింగ్ కాలేజీకి వచ్చారు కదా. ఇక్కడ మిస్ అయింది త్రూ నేను గేట్ కొట్టాలి, నేను స్టిల్ యూ హ్యావ్ ఏ ఛాన్స్ కదా. ఎంటెక్ చేయడానికి మీకు ఒక ఛాన్స్ ఉంటుంది. ఇక్కడ మిస్ అయింది అక్కడ తెచ్చుకోవాలని ఆ ఆస్పిరెంట్తో ఉండండి. ఆ ఆస్పిరేషన్ అనేది ఉండాలి. మీరు అదే ఆస్పిరేషన్తో ఇంటర్మీడియట్ జాయిన్ అయి ఉంటారు కదా, మరి అక్కడ మిస్ అయింది ఇక్కడ తెచ్చుకోండి, అంతే కదా సార్. అంటే సమ్ స్టూడెంట్స్కి ప్లేస్మెంట్స్ ఏమంటే యాక్చువల్లీ ప్లేస్మెంట్స్ ఏమన్నామని అంటారు.
కదా
ఎందుకంటే అందరూ పిల్లలు
సబ్జెక్ట్ నేర్చుకుంటాను.
ఇంకొకటి ఏంటంటే వీళ్ళకి మొత్తం ఆటోమేటిక్ మొత్తం ప్లేస్లో ఆల్మోస్ట్ అంతా కవర్ చేసేస్తారు. వీళ్ళకి 2-1లో వస్తున్నారు కదా, 2-1లో క్లియర్గా నోట్స్ కావాలి, మొత్తం జాగ్రత్తగా అంటే ప్రాబ్లమ్ అండ్ స్ట్రాటజీస్ సబ్జెక్ట్ మొత్తాన్ని చదివితే గేట్కే కాదు అని చెప్పారు. సబ్జెక్ట్ చెప్తున్నాను, గేట్ కోసం చేస్తాను బాగా చేస్తాను. Okay, now coming to, already you know what is probability definition. Already I have explained in the beginning. Probability is nothing but probability we can define for any event of a sample space occurred in a random experiment. So what is denominator, what is numerator? Probability of an event capital E of a sample space capital S in a random experiment is P of E is equal to probability of an event E. That is our question. Denominator is nothing but number of elements of S. Numerator is number of elements of E. Simply N of E by N of S. All possible outcomes goes to the denominator. Numerator is a part of the denominator. That is our question always. Probability of the entire sample space is always 1. Total probability. Because no chance is 0%. 0% means 0. 100% chance. 100% means 100 by 100. That is 1 or not. So probability never greater than 1. Probability never below 0. Is it? Probability is always oscillating between 0 and 1. Probability of null space means impossible event. Probability of impossible event is always 0. From this observation, probability of any event is always oscillating between 0 is less than or equal to P of E less than or equal to 1. Probability of any event is always oscillating between 0 and 1. Next, P of E bar is nothing but E bar or E complement. What is A complement? Mu minus A or not? So P of A complement is nothing but mu is nothing but universal set probability 1. 1 minus P of E. These are all basic observations, 100% these are useful. P of A intersection B complement. See, already I told you, probability means complete set theory. Their universal set, here it is a sample space. Their universal set is a sample space. Every subset of universal set is nothing but an event. That's it. P of A intersection. See, in Venn diagrams, even in set theory also, inclusive exclusive principle, you know, A intersection B complement is nothing but A minus A intersection B. Actually, A intersection B complement is A minus A intersection B. If I take probability on both sides, P of A minus P of A intersection B. Every set theory axiom is applicable here also. But what are required to me to solve the problems, we can use that only. What is De Morgan law application? What is A union B whole complement andi? A complement intersection B complement. If I take probability on both sides, complete set theory applications. Similarly, De Morgan law, one more law. A intersection B whole complement. A complement union B complement. De Morgan law applications. What is P of A union B? What is the meaning of union? Union means OR operation. OR gate acts. Intersection means AND operation. AND gate acts here. See, A union B meaning using Venn diagram. This is very important observation. You say this. A union B means A or B or both. Either A or B or both. How can I represent with Venn diagram? A means only A part. B means only B part. Or both means this part. Is it? Now, actually, you know one formula. In inclusive exclusive principle in 10th class only. What it is? What is N of A union B and N of A plus N of B. Here, this observation, see. Textbook format as usual, what is there in the book, if you follow, and in-depth preparation with some conceptual view, if you follow, what is the difference? You see here. Up to now, number of observations given to you. I didn't give single formula also. We have extracted formulas from our logical observation only. Here also, I have a doubt. Actually, union means R operation only or not? In set theory, union, in mathematical operation plus both are same. Is it? N of A union B means actually N of A plus N of B only. Logically, you think you are all computer science students. What is union? R. What is plus R? N of A union B means number of elements either in A or in B only. Y minus. Actually, what is N of A? Actually, theoretical proof is there for it. Leave all those proofs. Every proof comes from the logical view only. Is it? What is N of A union B formula? N of A plus N of B minus N of A intersection. My doubt is, okay, sir, theoretical proof is there, sir. In intermediate also proof is there. Even in discrete mathematics subject also proof is there for it. This is also because set theory, sets, relations and functions, one complete topic, very important topic is there. Even there also proof, they can ask the proof even in exam also. Leave all that proof. My logical doubt. N of A union B is nothing but N of A plus N of B. It should be like that only. Why minus N of A intersection B? In N of A, this is A and this is B. In N of A means number of elements in A or not? Means this common portion including common portion A will count. Even in N of B also including common portion B is counting. Means common portion we have counted 2 times or not? But I have to count only 1 time or not? Because of that reason minus N of A intersection B. If there is no common portion, no need to subtract. No common portion means A and B should be, intersection should be 0. Sorry, intersection should be 5. Intersection is 5 means that type of events are mutually exclusive. In case of mutually exclusive event, no intersection takes place. No doubt, N of A union B is just N of A plus N of B only. Same logic is applicable here. Probability. Tell me, P of A plus B. When, if disjoint sets, if A and B both are mutually exclusive, N of A and B is this only. Suppose if there is a common portion minus P of this is called addition theorem for two events. No addition theorem andi. Even problems also you can do it logically like this. No need. Addition theorem. Actually addition theorem for two events we can. Now, the thing is, P of A union B is equal to just P of A plus P of B. When? If A intersection B is equal to 5. A intersection B 5 means A and B both are mutually exclusive. One new observation here. Again, my sincere suggestion to all of you, not probability and statistics only, not only mathematics or discrete mathematics, even your data structures or algorithms, any, go through deeper levels. Once you open your book, if any concept is there, why, what? Why? What is the purpose of this particular step? Why it came? What is the reason? Is there any alternative way or not? Okay? Think. Definitely will get new ideas. You can crack, not GATE or EAC, leave it, even campus elections also. With very good package, you can crack. Even if you are not interested to write a competitive examination. Okay, so analytical and logical thinking, how? Not through directly through book only. You have to practice your own. Think in different ways, n number of ways. Now see this observation. See here, this is, you can observe P of A union B in every book. Now one new observation I will give you. What is the meaning of A union B? Already you have written. A or B are both. Is it? A or, once again I am writing, are both. A or B are both means either A can do or B can do or both of you can do. Simply I can use this sentence instead of use this. At least one of A, B or not. A or B or both means what is the meaning? At least one can do. At least one means either one or more. Either A can do or B can do or both can do. Meaning is same or not? At least one. See, point to be noted. R, alternate way. P of A union B. This is crucial observation. Listen carefully. P of at least one of AB. P of at least one of AB. Probability of at least one is nothing but total minus nothing is something or not? Something is nothing. Total minus all possibilities minus no possibilities gives minimum of one possibility or not? Total minus nothing is always something. Is it? Yes. Total is nothing but sample space probability minus nothing. Nothing means A should not and B should not. All possibilities minus no possibilities gives at least one possibility. Total minus nothing. Nothing means A should not do and means intersection B should not do. Same logic you can apply. Same P of A union B answer. If you see one problem you can solve using this application. Same problem you can solve by using this, you will get the same answer. 100% you will get the same answer. One can ask a doubt here. If you think in deeper lines, if you follow me clearly. Sir, actually this is easy, sir. Simply P of A union B is nothing but P of A plus P of B. If the data is available, I can substitute, I will get the answer. Here I have to take complex time waste, sir. What are you telling, sir? This is easy for me. Why you are giving unnecessarily all this? You can ask a doubt. If you ask that doubt, 100% that is a valid doubt. When? If it is for two events. Suppose if I ask a question for three events, suppose A, B, C, three events given to you. Same addition theorem extension for three events also I can give, but it is becoming lengthy. But it will become easy. If four events, five events, six events given to you, whenever you increase the number of events, yes, applying that formula is very, very lengthy. This is very, very, very easy. Okay, up to two events, no issue. And whenever you increase the number of events, This is far better. Okay, that's why this type of observation. Now, in a similar manner, I will write addition theorem for 3 events also. Where it is? P of A union B union C. Formula. Textbook format formula. 2 events extension formula. That is P of A plus P of B plus P of C minus P of A intersection B minus P of B intersection C minus P of C intersection A plus P of A intersection B intersection C. R. Now our logic you follow. A union B union C meaning is either A or B or C. At least one of A, B, C or not. At least one of A, B, C means total minus none. None of A, B, C. P of A complement intersection. This is easy. 4 events, 5 events, 6 events also you can extend accordingly. Okay. Okay. Ah. Now, before previous gate questions, still I will give some important tips to solve the problems easily. Tips means suppose if it is ah, key points on coins, key points on fair coins. Suppose if a single coin is tossed, if a single coin is tossed, then what is sample space and sample space? It contains two elements, head and tail. What is n of s? My denominator is not the sample space. How many elements in the sample space? That we are writing in denominator. Number of elements important. What is n of s and 2? Means whenever a single coin is tossed, irrespective of my question, you can fix the denominator as 2. Clear? Right. If two coins are tossed, if two coins are tossed, or coin is tossed 2 times. Here important observation. And two coins are tossed means here experiment repeated. Sir, how sir? You are tossing two coins means With a single hand, not possible to toss two coins or not. Either you have to use two hands or else two persons have to toss the coin. Is it right or not? A coin is tossed two times, outcomes. A single coin, sorry, two coins are tossed at a time, outcomes are symmetrical, meaning is same. Both gives the same sample space, don't confuse. Means a two coins are tossed, meaning is experiment is repeated two times. Like that you have to understand. What is sample space andi? You can observe maybe head on first and head on second, head head combination, or head first and tail second, head tail combination, or tail first and head second, or both may be tails. Is it? Yes. Now what is n of s here? Okay, 4. You are all observing as a 4, but my observation is different. This is not 4, this is 2 square. Sir, what sir? 4 and 2 square both are same. What are you telling, sir? Say this. Is it? Meaning is here 2 na 2 power 1 and is it? If a single coin is tossed, n of s is 2 power 1 and if two coins are tossed, n of s is 2 square. Don't say 4. 2 square. Suppose if 3 coins are tossed, it would be 2 cube. My intention is base is the 2. Coin is tossed 1 time, 2 times, 3 times, 4 times, even 100 times also base is the 2. Power only varies. Single coin is tossed once, power 1, 2 times, power 2, 3 times, power 3. Means what it is? Base indicates not only coin problem only, any experiment. Even it is your computer laboratory program execution also. If you say in a single trial of experiment, base is nothing but the number of outcomes in a single trial. Power always indicate the repetition number. If it repeats only one time, 2 power 1. 2 times 2 square. Is it understood? If 3 coins are tossed, if n coins are tossed, not only 2 or 3, suppose if n coins are tossed, what is denominator andi? Then n of s is equal to 2 power n. Suppose if a fair coin is tossed 20 times, irrespective of my question, what is the denominator? 2 power 20. 2 power 20, you can fix the denominator first. Numerator always comes from the question only. Is it? Yes. Clear? This is coin related. Now, using this information, I will give one previous gate question. Actually, in my pen drive and in WhatsApp also, direct questions, previous gate questions are there. I would have displayed there. But the problem it is not opening. There is some technical issue. I will try. Maybe in lunchtime I will try to resolve with your support. You are all technical people. Says it. Right. Clear? Now I will write one previous gate question. Try to solve that question logically. No logic. Sorry, no formula. Only logic. Now, I will write one previous gate question. I think this question they asked for CSC only. Question I will write. Why these people are coming? One previous gate question, it is problem. If 5 coins, actual question is 4 coins given, just I am changing as 5 coins. If 5 coins are tossed, the probability that at least one head, 1 minute, just a minute. 5 coins are tossed at a time. That also include. Simultaneously or at simultaneously meaning is at a time. The probability that at least one head and at least one tail will turn up. Will turn up means you have to observe minimum of one head and a minimum of one tail as an outcome. What is the denominator? You tell me first. What is denominator? How many coins are tossed? 5. If a single coin is tossed, what is denominator? 2. 2 coins means 2 square. 3 coins is 2 cube. 4 coins 2 power 4. How many coins you have tossed here? 5 coins means what is denominator? Denominator 2 power 5. Irrespective of my question, denominator is 2 power 5. Is it? Numerator is a part of the denominator. Out of all possible outcomes, what is required to me? That is a numerator. Numerator is a part of the denominator. Okay. Now you see the question. At least one head and at least one tail required to me. That is my favorable case. Is it? So, first I will write the denominator. What is denominator? N of S? N of S is 2 power 5. Solution. With limited number of steps, I will try to answer the question. Any doubt in this? All are clear? 2 power 5 denominator. Now coming to the numerator. Numerator is my favorable case. Means my question. That should be a part of this 32 only. Say this. Now think carefully. What is the question here? At least one head. First you read that sentence carefully and try to understand. At least one head and at least one tail means minimum of one head and minimum of one tail you have to observe. More than one head and more than one tail also no problem. Minimum one head you have to observe and minimum one tail also you have to observe. Means exact meaning is you have to observe both head and tail combination. Is it right or not? Our favorable case must contain both head and tail as well. Minimum of one head and minimum of one tail means minimum one head and minimum one tail required to me. Is it? Say this. Here I will try to write all 32 possibilities. I will not write not possible. How can I? Time waste. But I will give an idea. 32 cases I will try to write. All 32. Among all 32, all heads is one of the outcome or not? Among 32, all heads is one of the outcome or not? All tails is also one of the outcome or not? Is it? Listen carefully. Out all 32 possibilities I am trying to write. I am not writing. All heads is one of the outcome or not? All tails is also one of the outcome or not? Listen carefully. Is it my favorable case? First one, is it my favorable case or not? No. Why? Our favorable case must contain both head and tail together. Minimum one head and minimum one tail. Is it? So, this is not my favorable case. What about the second one? Here tail is missing. So, not my favorable case. Here head is missing. Not my favorable case. So, these are not favorable cases. Not favorable. This is very logical answer. Out of 32, these two are not favorable cases. Think carefully. In remaining 30 cases are there. In all remaining 30, compulsory head and tail combination is there or not? All are my favorable cases or not? Yes. Remaining 30 are my favorable cases. Remaining 30 are favorable cases. Therefore, what is required probability? Required probability. Remaining 30 are my favorable case means that is N of E is nothing but what it is? 30. All 30 are required probability is 30 by 32. 30 by 32 means who will cancel? 15 by 16. Okay. This is one previous gate question on coins. Now, related to die, some beautiful previous gate questions are there. Number of questions repeatedly they asked, and before giving those problems, I will explain some tips in die. Not yet completed. If you want to write, write it fast. Otherwise, you leave it. Okay. Now coming to dice. Key points on dice and key points on dice. Here also, if a single die is rolled, if a single die is rolled, what is sample space? 1, 2, 3, 4, 5, 6. What is n of s and? Okay, 6, but I want to see it as 6 power 1. Suppose if 2 dice are rolled, it would be 6 square, is it? If 2 dice are rolled, if 2 dice are rolled, then say this, first die, second die, every time 2 die problem, better you write like this, many questions you can solve easily. First die is marked with the numbers 1, 2, 3, 4, 5, 6. Second die also marked with the numbers 1, 2, 3, 4, 5, 6. Clear? You can observe one on first. Suppose if a dice are rolled at a time, maybe you can observe one on first die and one on second die. So that you can observe 1-1 combination. Or else you may observe 1-2 also, 1-3 also, 1-4, 1-5, 1-6. With 1-6 possibilities like this. Similarly, 2-1, 2-2 like that also 6 more or not. With 3 also 6 more. Total 6-6 are 36 possible cases. Then S is equal to like this. I am writing in a form of ordered pair 1-1, 1-2 and so on 6-6 like this. What is n of s? N of s is nothing but 6 square. Instead of 36, I am writing 6 square. See, already I told you. Whenever you repeat an experiment, base is nothing but the number of outcomes in a single trial only. Power always changes as a number of repetitions. Here, but see, whenever 2 dice are rolled, particularly here, from here onwards, question structure is different. Now, directly I will ask one probability problem. Irrespective of the question, 2 dice problem, what is the denominator? What is denominator for 2 dice problem? 36, fixed. Because 2 dice are rolled means denominator is 36. Numerator varies from question to question only. That is our event, favorable case. Now, my question is, if 2 dice are rolled simultaneously, the probability that, listen carefully, the probability that sum of the numbers appear on dice, sum of the numbers appear on dice is 9. Means what is the meaning? The number on first die plus the number on second die should be 9. Is it? Means out of 36 possible, numerator is a part of the denominator, I told you. Out of 36 possible days, how many of them give sum 9? Is it right or not? P of. My question is, probability of sum is 9. Suppose my question is like this. Denominator 36. Clear? Out of 36 possible cases, how many of them give sum 9 is my question. Is it? How many of them give sum 9? Tell me. Verify these ordered pairs. What is the minimum possible sum? First, minimum possible sum. 1 plus 1, 2. What is the maximum possible sum? 6 plus 6, 12. They can ask any question between 2 to 12 or not. Now my question is sum 9. Okay. Sum 9 means tell me what are the possible ordered pairs? 3, 6, 6, 3, 4, 5, 5, 4. Out of 36, there are 4 ordered pairs which gives sum 9. 4 by 36 or not? 3, 6 is one ordered pair. 6, 3 is the second ordered pair. 4, 5 is the third ordered pair. 5, 4 is the fourth ordered pair. Out of 36 ordered pairs, there are 4 ordered pairs which gives sum 9. Is it right or not? If it is a 2-day problem, easily better to avoid confusion, you can write die 1 and die 2 like that. Any question. Suppose sum 8 andi. Tell me, what is the numerator? Sum 8. 2, 6, 6, 2. Next, 3, 5, 5, 3, 4, 4. Total how many? 5 ordered pairs which gives sum 8. Is that right or not? Now, instead of verifying like that also, I will give one simple table format, means that you can use it as a technique. But for 2 days that technique also not required, this is better. But it will be very much useful for 3 days problem. I will give you the table format, you see this. Sum number of ways, numerator, only numerator part, sum. One table technique I am giving now. This observation, because without by hearting the table, no by heart. See, every theoretical view comes from the practical observation only. What is the minimum possible sum? 2. Maximum possible sum 12 or not? Sums, possible sums I am writing, you say this. This is our observation. What are the possible sum? 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. These are all possible sums or not? Listen carefully. For sum 2, how many ordered pairs are there? How many ordered pairs are giving sum 2 out of 36? Only one ordered pair, that is 1 comma 1. Is it right or not? Yes, for sum 2, one ordered pair. Even for sum 12 also, only one ordered pair, that is 6 comma 6. Okay, sum 2, only one ordered pair is giving. Sum 12 also only one ordered pair is giving, that is 6 comma 6. Means 2 and 12 both give the same number of ways. Sum 2, how many ways? One ordered pair it gives, that is 1 comma 1. Even sum 12 also, only one ordered pair is giving sum 12, that is 6 comma 6 only. Means number of ways to get sum 2 and 12 both are same. First and last both gives the same number of ways. That's why I have taken like this 2, 12. For both of them same way, that is only one way. Out of 36, only one ordered pair is giving sum 2 and 12 as well. Understood exactly? Now coming to sum 3 and sum 3, you just ask. Sum 3 means 2, 1, 1, 2, two ordered pairs. Even this side also sum 11, 5, 6 and 6, 5, two ordered pairs. 3 and 11 both gives the same number of ways. Rainbows you can take. Sum 3 and sum 11 both gives the same number of ways, two ordered pairs. Is it? From this simple logic, sum 2, one way, sum 3, two ways, sum 4, three ways. Check it if you have any doubt. 1, 3, 3, 1, 2, 2. That is ascending, this is descending. 10 and 4 both gives the same number of ways. Rainbow. You can guess it easily. He is the middle one. Before middle and after middle, number of ways are always symmetrical. Sum 5, 4 ways. This is 9. Already sum 9, 4 ways already we have verified. Sum 6, 5 ways. This is 8 and 8, 5 already we have verified. Sum 7, 6 ways. Here also 7. That gives the numerator information. Every 2 days problem, probability, 2 days problem, you can do like that. Okay. Ah. One previous gate question they asked. This is one previous gate question on today's problem. If two fair dice are rolled, the probability that the sum of the numbers on dice exceed 8 means the outcomes what you have observed. If I take the sum of them, it should be more than 8. Whenever it is a 2 days problem, what is the denominator? What is denominator? Directly I will try to answer the question. P of some probability. P of means probability of, don't confuse. Sum exceeds 8. Since it is a 2 days problem, what is the denominator? 36. Now numerator, wait. One more step I will write for more clarity. Before that, sum exceed 8 means it may be. Sum exceed 8 means what are the possible cases more than 8? P of exceed 8 means it may be either 9 or it may be 10 or it may be 11 or it may be 12 or not, maximum possible. Sum exceed 8 means either 9 or 10 or 11 or 12. All these are the possible options. Now denominator 36 and sum 9. Out of 36 ordered pairs, how many of them are giving sum 9? 4 ordered pairs. Already table given you see. R means plus. Out of 36 ordered pairs, how many of them giving sum 10? 3. R means plus. Out of 36, how many of them are giving sum 11? 2. 1. Plus 1. 10 by 36. 5 by 18 is the answer. Clear? This is one previous gate question. Okay? Like this, I will give you a logic for 3 days also. If 3 dice are rolled, then what is sample space and n of s contains 6 cube or not? 6 cube value 216. Total, whenever it is a 3 dice problem, our denominator is 216. 6 cube. Here also, just for clarity, I will write die 1, die 2, die 3. First die is marked with the numbers 1, 2, 3, 4, 5, 6. Second die also 1, 2, 3, 4, 5, 6. Third die also 1, 2, 3, 4, 5, 6. What are the minimum? What is the minimum possible sum? 1 plus 1 plus 1, 3. What is the maximum possible sum? 6 plus 6 plus 6, 18. So the sum is oscillating between 3 to 18. They can ask any question from 3 to 18. Clear? See here also possible sums. Just for clarity. 3 na? 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. Very clear. 3 and 18 both gives the same number of ways. Ordered pair 1, 1, 1 here. There ordered pair 6, 6, sorry, ordered tried 6, 6, 6 there. 4 and 8, 17 both gives the same number of ways. 5 and 16 both gives the same number of ways. 6 and 15 both gives the same number of ways. 7 and 14, 8 and 13, 9 and 12, 10, 11, two middle values are there. 10 and 11 both gives the same number of ways here also. But 2 days is easily, no need to take a rainbows like this, and already one table given, no need to take that table also. If I write D1, D2 like this, easily you can. But from 3 days onwards, it is difficult to remember. Why? Because minimum possible sum 3, maximum possible sum 18. Suppose if I ask a question, the probability of the sum of the numbers is 14. Sum of the numbers on dice is 14. If I ask a question like this, denominator 216, okay andi. What is numerator? Out of 216 possible cases, how many of them give sum 14? We have to identify. Simply like this. For example, sum 14, sum 14 means, for example, maybe 4, 4, 6 andi. 4 on first day plus 4 on second day plus 6 on third day. Or 6, 4, 4. 4, 6, 4. Not only this, 3, 5. 3 plus 5, 8. 8 plus 6 like this. 3, 5, 6 means these three numbers we can oscillate. 3 in first place, 5 in first place, 6 in first place, 3 factorial ways will come here. Here 6 will come. Here I have to add here 3, here 3 factorial means 6. Like that all possible. These are not, this will not give the final answer. All possibilities I have to verify like this. How much time it will take? It is a time taking process or not? Definitely. So instead of verifying like this, I will give one simple technique. Simple technique. Sir, like the previous table, sir. Even remember that, say, very difficult to remember the table 2 here. Why? Because for 2 days problem, sums are from 2 to 12. Easily I can remember the table. But here sums are oscillating from where to where? 3 to 18. Even if I take a table like that also, it is difficult to remember that table. So, same table information, same table, same rainbows. Okay, same table information. I will give the precised form with, I will give the precised form as a formula. Say this. Simple technique now. Sum like this. Sum we can denote with R. Number of ways I can denote, number of ways. That's it. If any question, if the sum is in between 3 and 8, sum is in between 3 and 8, you can apply this formula. R minus 1 into R minus 2 by 2. First time I am giving as a formula. Same table information I have converted in formula mode and don't confuse. If any question, if they ask between 3 and 8, then only you can apply. Suppose sum 7 and take R is equal to 7. That's it. Already you have taken a table. 9 and 12 both gives the same number of ways. Check it. 9 and 12 both gives the same number of ways. 10 and 11 both gives the same number of ways. So, since 9 and 12 both gives the same number of ways, but this formula you can apply from where to where? 3 to 8 only. If they ask me either 9 or 12, direct answer and 25 ways. Actually, how it comes, if you think in deeper lines, I am not writing directly as a formula. Those are from the generating functions. In discrete mathematics, there is one small concept called recurrence relation generating functions. From generating functions and multinomial theorem, you can get it. Okay. Now 9 or 12. Again, 10 or 11. 10 and 11 both give the same number of ways. Directly 27 ways is the answer. 3 to 8 completed. 9, 10, 11, 12 completed. Now how many remains? 13 to 18. Okay. Now 13 to 18 I will give one more formula. 13 less than or equal to r less than or equal to 18. 19 minus r into 20 minus r by 2. I will justify the logic what you have written. I will justify with one example clearly. 12:30, yeah? Okay. Not at 1 o'clock. 1 కాదు 12:30 to 1:30 అమ్మా. ఓకే. మీకు లంచ్ టైం అదా? ఓకే ఓకే ఓకే. See, I will give one previous gate question again. Using this logic, how can you save your valuable time? Okay. One problem. If 3 fair dice are rolled, the probability that the sum of numbers on dice is a perfect square. See, question is looking different. You say this. Sum should be a perfect square. Solution. How to answer it? First, perfect square sums. How many of them are having perfect squares? Possible sums. What are possible sums, Andy? 3, 4. Just for clarity, I am writing. But if you have a clear-cut idea, directly you can go to the perfect square. No need to write all this. 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. Among them, perfect square sums. How many of them are perfect squares? 4, 9, 16. That's it. These three only? 14? No, 14 is perfect square. Just these three only, is it? Yes. 4 is 2 square, 9 is 3 square, 16 is 4 square. P of, direct answer. P of sum is perfect square. This is my question or not? P of sum is perfect square means P of sum 4 or 9 or 16. Is it clear or not? 4 or 9 or 16. My denominator is 216 because it is a 3 dice problem. Rough work. Rough work means you can take a margin in right side of your notebook. Because between 3 and 8, one formula given. For 9, direct outcome given. Between 13 and 18, one more formula given. You have to apply accordingly. R is equal to 4, sum 4. What is the formula? R minus 1 into R minus 2 by 2 or not? That is nothing but 4 minus 1, 3. R minus 2 na? 4 minus 2, 2 by 2. 3 and. For sum 4, 3 ways. R means plus. For sum 9, how many ways? 25 ways directly given. See the table. Next, R is equal to 16. Formula 19, 19 16, 3 into 4 by 2, 2. 6, 28 plus 6. Clear? Every 3-line problem using this logic you can do. Actually, in 2022 GATE exam, I think so, for EC branch, they asked one question on voltages also. If voltages are rolled simultaneously, the property that sum of the numbers appearing on fold dice is 22, they asked. For problem, minimum possible sum, 4. 1 plus 1 plus 1 plus 1. What is the maximum possible sum? Question they asked it is sum 22. Okay. After break, we'll continue.